Internal bonding refers to the electrical continuity within the metal armor of the cable. This means the armor is electrically connected together at all joints and terminations. Integral bonding refers to the electrical connection between the metal armor of the cable and the grounding conductor inside the cable. Here, the armor and grounding conductor are bonded together at all joints and terminations. If the metal-clad cable's outer jacket is not an approved ground path, and the installation is within a plastic non-metallic box, then the grounding conductor inside the cable needs to be bonded to the grounding screw of the box. Section 314.3 states that metal-armored cables can be used in non-metallic boxes, but it does not specify how to provide a ground path. Section 330.40 requires the use of approved connectors when terminating metal-clad cables. Section 314.3 finds its usefulness in situations where the metal armor of the metal-clad cable is used as the grounding path. An example of this is when the metal-clad cable is terminated in a metal box that is grounded. Thus, since the metal-clad cable's outer jacket is not an approved ground path, the grounding conductor inside the cable must be bonded to the grounding screw of the plastic non-metallic box. Section 330.40 dictates the necessity of approved connectors, ensuring proper bonding and grounding. Therefore, the grounding wire of the metal-clad cable must be connected to the grounding means within the non-metallic box. This means a grounding screw or other approved method of bonding to the box's grounding system. The purpose of bonding is to create a low impedance path for fault current to return to the source, thus tripping the overcurrent protection device, like a circuit breaker or fuse. A non-metallic box does not inherently provide a grounding path, which is why the grounding conductor within the metal-clad cable is crucial. Approved connectors for metal-clad cable are designed to maintain the integrity of the grounding path, even when transitioning to a non-metallic enclosure. When the metal jacket of the metal-clad cable cannot be used as the ground path, the internal insulated grounding conductor becomes the primary means of ensuring electrical safety. The size of this grounding conductor is determined by the requirements outlined in the National Electrical Code, often referred to as NEC, and depends on the size of the circuit's overcurrent protection. When terminating the grounding conductor to the grounding screw in the non-metallic box, ensure a tight and secure connection. A loose connection can impede the flow of fault current and compromise safety. Regularly inspect these connections, especially in environments prone to vibration or corrosion, to ensure their continued integrity. The NEC Article 250 provides detailed requirements for grounding and bonding, including conductor sizing, acceptable grounding electrodes, and methods of bonding. Understanding these requirements is essential for safe and compliant electrical installations. Always consult the latest edition of the NEC and local amendments to ensure compliance with current regulations. In situations where the equipment grounding conductor runs through a metal raceway, such as metal-clad cable, and terminates in a non-metallic box, it's vital to ensure that the grounding path is continuous and effective. This is because the metal raceway, while providing some degree of physical protection, cannot be relied upon as the sole means of grounding when it connects to a non-metallic enclosure. The internal insulated equipment grounding conductor acts as the dedicated ground path, supplementing the metal raceway's grounding capabilities. One important consideration is the selection of the appropriate size of the equipment grounding conductor, often referred to as an earth ground wire, based on the overcurrent protection device protecting the circuit, as specified in NEC Table 250.122. This table dictates the minimum size of the grounding conductor required to safely carry fault current back to the source in the event of a ground fault. Failure to use an adequately sized grounding conductor can result in a higher impedance ground fault path, which may not trip the overcurrent protection device quickly enough, posing a potential fire or shock hazard. Moreover, ensure that all grounding connections are made in accordance with NEC Article 250, which outlines the proper methods for bonding and grounding electrical systems. These methods include using approved connectors, bonding jumpers, and grounding electrodes to establish a low impedance ground fault path. When installing metal-clad cable in a non-metallic box, the method of securing the cable to the box is also crucial. NEC Section 314.17 provides requirements for cable entries into boxes, including the use of appropriate fittings or connectors to ensure secure and strain relief connection. These fittings not only protect the cable from damage but also maintain the integrity of the grounding path by providing a reliable mechanical and electrical connection. It's essential to choose connectors that are specifically listed for use with metal-clad cable and are suitable for the environmental conditions in which they are installed. For example, in damp or corrosive environments, use connectors that are rated for wet locations and are constructed of corrosion-resistant materials. Furthermore, NEC Section 300.4 addresses the protection of conductors and cables from physical damage. When running metal-clad cable through framing members or other structural elements, ensure that the cable is protected from abrasion or penetration by using appropriate bushings, grommets, or other protective devices. This is particularly important when installing cable in concealed locations where it may be subject to damage during construction or renovation activities. When dealing with electrical installations, it's crucial to follow all applicable codes and standards, including the NEC, as well as local and state regulations. These codes and standards are designed to ensure the safety of people and property by minimizing the risk of electrical shock, fire, and other hazards. Consulting with a qualified electrical inspector or engineer can help ensure that your electrical installations are safe, compliant, and meet all applicable requirements. Remember that electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from harm. Always energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. The NEC Section 314.3 permits the use of metal-clad cable in non-metallic boxes, provided that the grounding requirements of the code are met. This means that the equipment grounding conductor within the metal-clad cable must be properly connected to the grounding system of the electrical installation. When terminating metal-clad cable in a non-metallic box, ensure that the grounding conductor is securely connected to the grounding terminal or busbar in the box. This connection must be made using an approved method, such as a grounding screw or pressure connector, and must be torqued to the manufacturer's specifications to ensure a reliable and long-lasting connection. In addition to grounding the equipment grounding conductor, it's also important to ensure that the non-metallic box itself is properly supported and secured. NEC Section 314.23 provides requirements for the support of boxes, including the use of appropriate mounting hardware and methods. When mounting a non-metallic box, use screws or other fasteners that are compatible with the box material and the mounting surface. Avoid over-tightening the screws, as this can damage the box and compromise its structural integrity. The proper installation of metal-clad cable in non-metallic boxes requires a thorough understanding of the NEC and other applicable codes and standards. By following these requirements and using approved materials and methods, you can ensure a safe and reliable electrical installation. Always remember to prioritize safety when working with electricity and consult with a qualified professional if you have any questions or concerns. When running metal-clad cable through walls, floors, or ceilings, be sure to comply with NEC Section 300.4, which requires that conductors and cables be protected from physical damage. This may involve using nail plates, bushings, or other protective devices to prevent the cable from being damaged by nails, screws, or other objects. In addition, NEC Section 320.23 specifies the requirements for the support of metal-clad cable. The cable must be securely supported at intervals not exceeding 6 feet and within 12 inches of every box, cabinet, or fitting. Use cable ties, straps, or other approved methods to support the cable and prevent it from sagging or becoming damaged. When installing metal-clad cable in hazardous locations, such as areas where flammable gases or vapors may be present, be sure to comply with NEC Article 500, which provides requirements for electrical equipment in hazardous locations. This may involve using explosion-proof boxes, fittings, and other devices to prevent the ignition of flammable materials. When working with electrical systems, It's always important to follow safe work practices and use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Remember to de-energize circuits before working on them, and to test circuits to ensure that they are de-energized before beginning work. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job.